Let's talk about our basic trigonometric functions. And before I do that, I want to cover a procedure or a protocol that most textbooks follow when drawing up a triangle. So one thing we should be careful to follow is that if I'm drawing a triangle, it's very common for us to use Greek letters to label the angles. And so I'm just going to call this guy down here alpha and this angle beta, and we'll call this angle gamma. Most textbooks use this little tradition of labeling things that whatever side is opposite of angle alpha, they call that A. And side B would be found opposite angle beta. And usually side C is found opposite angle, angle gamma. And from problem to problem, you're not always going to use these same Greek letters or side lengths, but if a problem leads out describing a triangle by saying, hey, side A is this, angle beta is this, the assumption is that you're going to be drawing your triangle this way, putting angle alpha opposite side A, angle beta opposite side B. And that way you're going to draw the same picture that they're trying to describe to you. Okay, let's get into our 6 trigonometric functions. And so if you look at any math book, often you will see the trigonometric functions defined a few different ways, though they are always describing the same thing. And so I want to look at sort of the most useful definition and the one that we will definitely be using the most, and that is Soh Cah Toa, okay, the right triangle definition. You may have seen this before, or you may be thinking, what the heck is Soh Cah Toa? But let's go through that. Sohcahtoa is a helpful way to memorize how to set up my trig functions. Let me describe for you for a second what a trig function does. For any trig function, let's just pick on sine. What you plug into sine is some angle. You need to tell the angle that you are standing at by plugging that into your sine function. And what comes out of the sine or cosine or tangent function is some ratio. You're going to end up dividing 2 of the side lengths of that triangle. And which 2 side lengths you divide depends on, well, 1, where you're standing, but 2, what trig function are you talking about, sine, cosine, or tangent? You see, sine of some angle, I'll just use angle alpha, is defined as the side opposite that angle over the hypotenuse of that triangle. And that's what we see here in SOH. Opposite over hypotenuse is how we find sine. And if I want to look for my cosine function of any angle, then I need to take the side that's adjacent to that angle, that means right next to it, and divide it by the hypotenuse of the triangle. And so that's what Ka is telling us to do. Take the adjacent over the hypotenuse to find cosine of your angle. And then lastly, the tangent function, you might be seeing it, tangent of any angle is equal to the side that's opposite of that angle over the side adjacent to that angle. Opposite over adjacent is how you find tangent. Now, these trigonometric functions also have a reciprocal that goes along with it. So for example, if I were to write the ratio hypotenuse over opposite, that's the reciprocal of the sine function. That is known as cosecant of angle alpha. CSC, cosecant of alpha. If I looked at the hypotenuse over the adjacent, that's the reciprocal of cosine. That is secant of alpha. And then lastly, if I want the reciprocal of tangent, if I took the side adjacent over opposite, that would be cotangent of angle alpha. So these are your 6 trigonometric functions. You really only need to know the top 3 here, sine, cosine, and tangent, because to get the reciprocals, you just flip them over. And again, one of the best ways to memorize that is Soh Cah Toa. So let's just quickly set up a triangle and find some values here. So let's say I've got a triangle here, and I'll say this is alpha, This is beta. There's nothing special about where I'm putting them, but once I do place the side or the angles, then I kind of know which side B should be, right? Didn't we say that B should be opposite of angle beta? And A should be opposite of angle alpha, and C should be opposite of the hypotenuse, or angle gamma, if you want to call it that. I'm sorry, opposite the right angle. Let's just find a couple of these. Let's find sine of angle alpha. So the angle tells you where you're standing. Okay, I'm standing at angle alpha. Now sine, if I remember, Soh Cah Toa, sine means look for the side that is opposite your angle and divide it by the hypotenuse of the triangle. So standing at alpha, side A is opposite, and C is the hypotenuse of my triangle. So this should be A over C. Let's try cosine. Cosine of angle alpha. If I want cosine of angle alpha, cosine says take the side adjacent to your angle and divide it by the hypotenuse. So the side adjacent means right next to it, and divide it by the hypotenuse. So this would be B over C. And again, it's not like sine of alpha is always A over C, and cosine of alpha is not always B over C. From problem to problem, these are going to change. They might be numbers, right? So it's not like it's always A, B, and C, but we're just using it in this diagram to set up these ratios. Let's change things up and use a tangent of angle beta. Let's give that a shot. So tangent of angle beta, well, now I'm standing at angle beta, and tangent says to take the side that is opposite of your angle and divide it by the side adjacent to your angle. Opposite of beta is B, and adjacent to beta is A. I know the side C is also right next to angle beta, but that's the hypotenuse. That's not ever going to be considered an adjacent. It's hypotenuse. And so this would be opposite beta over adjacent to beta, B over A in this case. Now if you notice, I didn't do any from the right angle. Like if I want to call this angle gamma, I didn't use that angle. And let's talk about why for a second. Tangent of gamma, what would that look like? Well, tangent is supposed to be opposite over adjacent. So the side that's opposite of this angle is not officially an opposite, it's hypotenuse. And then if I try to find out the adjacents, well, A is adjacent to that angle, but so is B. So which is actually the adjacent? You see, this definition of Soh Cah Toa breaks down when your angle is 90 degrees or 180 degrees or any multiple of 90 degrees. Then I need to use one of those other definitions for a trig function that you see in a textbook. But by and large, the majority of problems we will be doing will be looking for sine, cosine, or tangent of a non-90 degree angle. And there's one more thing I want to get at real quick that we'll be needing in upcoming lessons, but I mentioned to you that any trig function, whether it's sine, cosine, or tangent, so let me just pick on cosine, what we do is we plug in an angle, remember that tells us where we're standing, and what comes out, or the result of the trig function, is a ratio, either the opposite over adjacent or adjacent over hypotenuse or whatever. In this case, it's adjacent over hypotenuse, right, since we're talking about cosine. Now, sometimes I know the angle and I'm looking for the ratio, but sometimes I know the ratio or the side lengths and I need to find the angle. This thing can work backwards, we can say. There's an inverse. So I can also say that cosine inverse, it means we're going to run the thing backwards. And what I do there is I plug the ratio into the trig function and out comes the angle. And so we could use our calculator to help us establish an angle based on the side lengths of a triangle. And another way you may see this written, because some books use that little, looks like an exponent of -1, but really it's read as cosine inverse. Some books write arc cosine. So that arc notation, whether it's arc sine or arc cosine or arc tangent, it is 100% the same as the inverse function. It's just tomato, tomato, two different ways of writing it. Okay, I hope this helped a little, and look forward to seeing you in the next video.